Ever wondered if something can exist in two places at once? In the quantum world, it can. Welcome to the enigmatic realm of quantum physics, where the rules of the game are incredibly different from the familiar world we live in. It's a world that shatters the rigid pillars of classical physics, introducing phenomena that seem to defy logic and common sense. One such phenomenon is quantum superposition. Imagine flipping a coin. In our world, it will land either heads or tails. But in the quantum realm, it's akin to a coin landing both heads and tails at the same time. This is because quantum particles can exist in multiple states simultaneously, a mind-bending concept known as superposition. So in the quantum world, things can be much different than our everyday reality, but hold on, it gets even stranger. Imagine if shaking one snow globe caused another 1 mile away to react instantly. Sounds impossible, right? Not in the quantum realm. Here we encounter a phenomenon known as quantum entanglement, a curious concept that flirts with the limits of our comprehension. Essentially, quantum entanglement refers to a special bond between particles. When two particles become entangled, they form an intimate connection that transcends space. The state of one particle immediately impacts the other, no matter the distance between them. Picturing it might be challenging, so let's return to our snow globes. Shake one and the other responds, regardless of whether it's across the room or across the universe. This immediate, long-distance relationship might seem like the stuff of science fiction, but it's very much a part of the quantum reality. This spooky action at a distance, as Einstein called it, challenges our understanding of the universe. What if I told you that light can behave both as a particle and a wave? Would you believe me? Now, this might sound like a paradox, but welcome to the world of quantum physics where the impossible becomes possible. This strange duality is what we call the wave-particle duality concept. Take light, for instance. We know it as waves radiating from the sun or a bulb. But it's also made up of particles called photons. Just like actors playing multiple roles, these photons can be both particles and waves. Let's simplify this with the famous double-slit experiment. Imagine firing tiny particles at a wall with two slits. We would expect them to act like bullets, right? But they don't. They create an interference pattern on the wall behind, just like waves would. So light can be both a particle and a wave, depending on how we look at it. The quantum world is indeed full of surprises. Let's take stock of our journey into the remarkable realm of quantum physics. We began with the extraordinary notion of superposition, a revolutionary quantum concept suggesting particles exist in numerous states at once, settling their reality only upon observation. It's as mystifying as being in multiple places at once, selecting your position only when observed. Superposition defies conventional laws, challenging our understanding of reality. It proposes that something can be present in different places simultaneously, offering a fresh perspective on existence. Post-superposition, we examine the enigmatic world of quantum entanglement, a phenomenon where particles separated by distance seemingly communicate instantly, bound by an unseen thread that defies space and time. Einstein famously called this spooky action at a distance. Quantum entanglement is not just theoretical, it's proven. Particles can share information instantly across vast distances without apparent communication. It's like particle telepathy, shaking our comprehension of space, time, and reality. Delving further, we discovered wave-particle duality. Particles can behave as both particles and waves, blurring the boundary between matter and energy. Picture being simultaneously a grain of sand and an ocean wave. That's the quantum realm. This concept disrupts our typical perception of reality, encouraging us to imagine a world where things aren't as straightforward. A world where particles can inhabit multiple states, stretching the limits of our understanding. Superposition, entanglement, wave-particle duality, these ideas challenge our conventional understanding of reality. They prompt us to question our beliefs and reevaluate our universe's fabric. Quantum physics, a domain thriving on mystery and paradox, steers us into the unknown. It extends the reaches of our imagination and challenges our knowledge, turning the impossible into reality and the unbelievable into undeniable fact. Despite intricacies, quantum physics is perpetually captivating. It's an exploration, a plunge into the unknown, an embodiment of the spirit of discovery, urging us to probe the universe's depths. As we conclude this quantum physics primer, bear in mind this is just the start. There's an expansive world to investigate, filled with unanswered queries. So remember, the quantum world is as fascinating as it is complex. Hence, continue questioning, wondering, and exploring the universe's enigmas.